So I've started investigating the weird FM dropout that's occurring, and I found it's getting a lot more common now. In fact, most of the operation is just silence now. So I've been measuring a lot of voltages, and I'm going to move to measuring resistances while the unit's off, which is just the easy place to start looking for an open resistor, possibly a resistor that when it heats up, it goes open. That would explain, or goes high value, and that would explain this. I was probing around the bases of the tubes here, which are for the IF stages, and just by tapping my probe on what I believe is the grid, I get crackling out of the speakers. So it certainly tells me that everything is fine, at least past that. Possibly there's no signal, but at least all the audio stuff is fine. I checked all the voltages of the output tubes and everything, and they're all fine. They're biased correctly. The B plus is fine. So it's definitely not an amplifier issue, and it's not a demultiplexer issue. So it's definitely in this can. There's probably either a resistor or a capacitor that is going high value or open as it heats up. That's my best guess. So it's going to take me a while to find it, but I will find it, and I will replace it. Sounded a little bit like Liam Neeson there. So I've been trying to track down any bad components that may be causing this weird FM issue, and I've been noting down voltages on all the pins of the tubes, and the grids seem to be a little bit high. The grid on the FM RF converter here, which I've put the shield back on it. The grid is supposed to be -2 to -4 volts, or somewhere around there. It's only about -0.8, 0.9. It's a little high, but it seems to be working even with it that high. So I'm going to look into that. But what I'm more interested in is a particular resistor that I found that is definitely not correct. As with all high value resistors, oh my god, I hate this flashlight. High value resistors don't usually tend to fare so well, and there's one of them in the audio circuit. It's right there in the center, the red green. That's a 2.2 megohm resistor. Now, I suspected that could be an issue. It's in the ground of the FM, so it's used as the AM AVC line, but when you're in FM mode, that becomes the ground. And I'm going to just test across this and show you what it reads. So it's supposed to be 2.2 meg, and it's reading 144K, and there's nothing in series or in parallel with that. That is its normal resistance. And I was able to before get it to read 1 megohm, but that's still way off from its 2.2 megohm. So I think that may be damaged internally, and its low resistance may be pulling the voltage down periodically. I think it's thermal related, because as the resistor heats up, it expands, and that probably changes its resistance, which changes the current through it, which either causes it to heat up more or cool down, and then it contracts and the cycle begins again, and that's how you get this oscillating effect over a long period of time. What I tried was I tried to use my my compressed air. You turn it upside down, you get the propellant that comes out, and it's about -40, 47 degrees Celsius. So it's really good for targeting components. You can very accurately spray it on components, and you can quickly change their temperature and see. And it's a good way of isolating which component is at fault. And I tried that for basically everything in the audio circuit or in the radio circuit, and I couldn't get that to basically have any effect whatsoever. So it doesn't seem to be. I mean, I'm debating whether it's thermal or not. But out of all the components I tested, that one resistor is the only thing that tests not what I'd expect. I mean, there's a few things that are out of tolerance, but they're not very far out. Not far enough that I'd need to bother replacing. So I'm going to check my parts bin to see if I have a resistor that's that big. Hopefully I do, or I can at least make something that big by putting a couple in series. I think all of these are half-watt resistors. Yeah, that looks like a half-watt. I maybe only have quarter watts. Let me find out if I've got another one, because if I do, I'll just whack it in there and see if that changes anything. Well, I don't happen to have any half-watt 2.2 megohm resistors, but I did find a quarter watt, and I mean, at 2.2 megohm, even with 100 volts across it, the current through it is pretty negligible. So I'm going to put this in and just try it out, and if it solves the problem, next time I order from Mouser, which will probably be soon, due to another project, I'll just throw in a proper wattage resistor. Not that it probably really matters that much, but I'd feel a lot better putting the proper resistor in. This is just for testing, so hopefully that solves the problem when I whack it in there. So what I've changed that resistor, and it reads the same in circuit, and I think I missed. This is the resistor here, and there's a strange loopback path that I think I'm reading with some caps in it, and it keeps drifting around. I clipped it out of the circuit, and it read 2.2, almost spot on. I changed it anyway, but I've got the original. I'm probably going to put the original back in. I haven't been able to reproduce the issue since I put this new resistor in, but one thing that I did notice was on my Variac. My Variac is not a terribly expensive one, and I mean, I think I paid like 80 bucks for a 12 amp Variac, and I mean, it's perfectly fine, except the dial is not accurate. So I normally just run it at where it says 125, and that seems to be normally line voltage. However, when I checked it, my house happens to have quite low mains. It hovers around 113, 114 volts. So I was only giving the radio about 110 volts. Now this radio, it explicitly says on the back 120 volts. So I tweaked the Variac, so I'm giving it 119 now. So much closer to its original value, or desired value anyway. And I've noticed a bunch of voltages have actually improved. They've gone, some have actually gone down more towards what they're supposed to go to, including a lot of the negative voltages. For example, the drive voltage on the grid of the 6AQ8 is now about minus 1.3 volts instead of the 0.8 I was getting before. And a lot of the plate voltages have actually dropped as well. So everything is sort of settling in when I run it at closer to 120 volts. So I'm wondering if when I powered it up that time, I was running it a little bit under, and some of the biasing networks weren't biasing correctly, and it was sort of some weird thing where it was drifting in and out. I honestly can't tell. I didn't check the line when I had that issue, because I just assumed it was 120. And I remember when I brought this up the first time, and I mean, I always bring it up slowly on the Variac. I don't try to stress the heaters. And I notice it really requires like very close to full line before it operates correctly. So maybe, I mean, optimistically, that's the best possible thing, but it definitely wasn't that that resistor, that 2.2 megohm, was not the issue. Definitely not the issue, but I'll keep monitoring it now that I've got it tweaked to exactly 120 volt and see what happens.
So this radio uses somewhere around 40 to 45 watts, and it's very stable.
So I think I'm going to call it quits for tonight. It's getting a little bit late, but at this point, I've got to conclude it's probably a bad cap or something. I haven't been able to cause that issue again, and I'm pretty sure it's definitely an issue with the radio. It's not a line voltage issue. It's not some weird interference issue. I'm sure that this is an issue with the radio. It's probably a cap or something, and the fact that it's been used, it's been on, has caused it to sort of reform a little bit and sort of stay stable. But I'm hoping that by leaving this off all night, coming back to it tomorrow, it will have settled back down, and I'll be able to get some readings once it's failed. See, the problem is all the voltages and stuff I've been reading are all with it working properly. So unless I can get it to fail again, I can't compare them. And if I can't compare them, I'll never find out where the problem is. And I mean, I could go through this and replace every single component and still not find it. So I'll call it quits for today, and hopefully I can find this another day. So I finally decided time to get the scope out, and fortunately it doesn't fit up here on the actual top itself. So the floor is my workbench. That far too often is the case. Anyway, so I've been just looking at the signals mostly in the actual tuner part, and they're actually quite good so far. I just wanted to take the opportunity to show you what I noticed on the FMD multiplexer. So what you're currently looking at is basically after both diodes, and it's tuned into a station right now, and you can see even while it's running, but if I stop it, you can see it's not perfectly balanced, but it's relatively round, and it looks generally okay. Now if I check the other side, you get basically the same thing. It looks relatively good, and of course there's audio modulated on this. Now if I go in between the two diodes, this is where where you can see the modulated signal here, and the radio's on right now, so I think they just switched to a commercial or something. So of course you can see the audio there. So everything looks fine. Now if I go back to my 10 microsecond time base, so remember that this is what one of those diodes looked like. Now if I switch to one of the new diodes I installed, this is what it looks like. Now I don't know if you can tell, but it's a little bit sharper, more cut off on the bottom. Now if I look at this one, it's not as rounded. It looks like it's saturating more. Because if you look at the other side, actually no, now it doesn't look so bad. So I think I might know why they chose those diodes that have a very shallow IV curve. The easiest way to look to sort of see this is if you look at, this is the audio output from that channel. This is the one that does have the original diode in it, and if you just stop it, okay, wow, it's always going to be. Why does it have to switch to a commercial right at the moment that I want to demo something? All I want is a really busy waveform. There we go, something like that. Now just remember what this looks like, and I mean everything looks pretty normal.
It's relatively smooth. Now, if I instead switch over to the other channel, the one that's got the new high-speed diodes in it, and I look at the that signal, I don't know if you can tell, but there's a lot more. It almost looks like there's a lot of square waves. I mean, it's very sharp. In like almost like quantized steps. Obviously, there is no quantization, but that's what it looks like, and it's very interesting. It's not. It's basically got a lot more high frequency content in it. It's like the cutoff is much sharper with that versus the old, which is a lot smoother. So I will be putting the old one back in because I see no reason in replacing it. Yeah, you can very easily, at least I can. I'm not sure how the 30 frames per second this is going to look, but I can clearly see a difference between the original diode and the new diode. There's a lot more. There's a lot more like almost like a dead zone. And there's a lot of flat points, whereas this is a lot more, a lot smoother a signal. So yeah, because when I actually checked I actually did check which one was which, and the channel I thought was better sounding was actually the left channel, which was this one. So definitely, or sorry, this is the right channel. This is the left channel. So the one that I thought sounded better is indeed the one that is the original. So that was an interesting experiment. It failed, but at least I understand why. So I'll be putting that back. I didn't destroy the old component. So, but I've been looking at signals on the radio here. Hopefully that is not loud enough that you can't hear it and YouTube doesn't get mad at me. So you can see, let's pick a random point here. This is pin 1 of the, so this is the plate of the 6AQ8, and it is a very big signal, and that is our 9 megahertz, and that is a beautiful looking sine wave. That is quite nice. And if we look at pin 2, which is the grid at a much smaller volts per division, again we get a nice sine wave, and this is 106 megahertz. So that minus our 9 megahertz is the tune frequency. So as I change the tuning, you can see the frequency down there changing. So that's interesting. So when I start out at the bottom end, which is 88 megahertz, and I go up, obviously our frequency increases as we expect it to, and then the amplitude drops off, and about 103 megahertz, this basically dies, and we get nothing. And I suspect that this is due to effects of the probe, because of course whenever you put the probe on, the radio dies, it goes out of sync, or the frequency that you've tuned changes. So it may just be an effect of that, but I wouldn't expect that to stop, because that would be the intermediate frequency. I'm not entirely sure what's going on there. I'm assuming it's just capacitive effects or inductive effects of the probe being on that node, which is basically directly coupled into the grid of the tube on pin 2. And we can look at some other things too. So on the other side of that IF transformer, we have again our 10 point, in this case it's around 10.7, So you can see our audio is modulated on that quite nicely. Then the next IF transformer, we have a much higher amplitude signal there, but everything still looks perfectly fine there. And then the other side of that, again perfectly fine, a little bit offset, but perfectly fine. Moving down again, this is the this would be pin 7. This would be pin 5 of the 6BA6. So this is the plate of the 6BA6. So we have our we have really high amplitude. That's about 15 volts peak to peak coming out of that. Still at the 10.7, and I believe pin 6 or 7. Must be pin 6 if I remember correctly. Yeah. So pin 6. This is where we see our first audio signal without any local oscillator in it. So this is native, and it looks fine. I mean, it's a little bit weighted to one side. All of the signals appear that way, either high or low depending on where I'm looking at them. I'm not sure if I should be concerned about that or not. And going into the detector, the ratio detector, so this is pin 1 of the ratio detector, which again looks pretty okay. And pin 2, again, fine. And then pin 5. Okay, now that's pin 7 of the ratio detector. So you can see that's very to one side. Now that is a dual diode, so I believe, correct me if I'm wrong, but I believe that is expected. And pin 5 should be basically the same, but the other way. Yeah, so this is the cathode of the 6AL5, which is a dual diode with separate cathodes. So you were just seeing the plate, and this is now the cathode, and they're opposite of each other. So everything looks fine. I mean, we're getting signals all the way through it, and they all look to be pretty good, except for that one part of the FMD multiplexer, which I'm going to be replacing. And I mean, everything looks fine. So I haven't been able to get the same issue with the tuner that I did that one time. I mean, it happened twice, and it never happened again. So I don't really know what I can do about it. I'm tempted to just put this all back together again and just, you know, just wait and see. I'm gonna have to take it all apart again when I refinish the cabinet in a few weeks. So if it happens again before then, I'll you know, of course, when I take it apart, I'll investigate it again, and hopefully I'll have some more ideas. But I really need a way of testing this properly. I really need a capacitance tester that can test things lower than 1 microfarad. That's the problem. My capacitance meter only goes down to a microfarad, and basically all the caps in this are much smaller than that. I mean, they're on the order of, you know, 1 nanofarad or so. So I need to get on that. I need to find something and get it, because it's going to make this and a lot of other projects a hell of a lot easier. So the only other thing that I've really noticed that I may want to fix is I've noticed the high frequencies in the audio are distorted, and
I'm not sure exactly where to look as to what might be the issue with that. That might just be the way that this radio is. I mean, if I had another one of these to compare it to, it would be a lot easier, but I don't, unfortunately. So, other than that, everything seems fine. So I've tested the stereo for the tape input, and it does work properly. Although I have to sort of jam a piece of plastic in the two prongs to get it to disengage the mono. So I'm going to be making a cable for that soon. I have to find one of those long RCA jacks that I can make a cable with. And other than that, everything seems pretty good. The treble control is a little bit scratchy now. So that's, I mean, all the other ones stayed pretty good after I cleaned them. That one didn't. So I'm going to clean it again, and this time I'm gonna really work it in as much as I can. I lost the little red nozzle that goes on the end of the can, so you can really get it in there. So unfortunately, it's not easy to get it inside the pot. So I'm gonna try again. But if I have to replace this pot, it's a double gang pot, one for each channel plus the switch on the end. So I think this is a standard shaft. So I'm going to I mean, I can get another switch that's equivalent to this. It won't look exactly the same. It won't have this interesting rotary part on the end, but I can replace that if that control doesn't get any better. But I'll do that later on. So I think that's enough waffling for now. I'll change up a few things, and probably next time you see this, it'll be in the cabinet, all reassembled.